Hi, my name is Abdelrahman. Today I'll be explaining to you the topic of friction. So let's start and take this slowly. What is friction? Friction is the resistance that one surface or object encounters when moving over another. Friction is also associated with Newton's second law of motion. You might be wondering what is Newton's second law of motion and how does friction pitch into this? Well, Newton's second law of motion states that the acceleration of a system is directly proportional to and in the same direction as the net external force acting on the system, and inversely proportional to its mass. Friction is the force that opposes the motion past each other of objects that are touching. For example, if I have a certain object on a certain surface and I push this object, the resistance I feel is not of anything but friction and the weight of the object. Friction basically opposes my push to the object and basically stops me from moving it, and I need a certain amount of force to be able to move this object. So let's look at examples, and we're going to start simple and advance from there. But first, let's look at the formula for friction. As you can see, the formula is F equals the coefficient of friction multiplied by the normal force. Normal force can also be stated as N, or sorry, normal force is represented as N. So let's look at our first example. A 5 kilogram box on a horizontal table is pushed by a horizontal force of 15 newtons as shown on the right. If the coefficient of friction is 0.4, will the box move? So in this question, as you can see, we're just looking for the smallest force that could make the box slide along the table. So let's take this in a more simpler way. So the first step is we have to draw a free body diagram. As you can see, a free body diagram is basically drawing the object and basically label every force that might be working on the object itself. So as you can see in the free body diagram here, as you can see by the mouse, there's 15 newtons pushing to the left here, and F, or the friction, is pushing the other way around, and there's the normal force, and there's the 5 kilograms, or basically the weight of the object. So first of all, let's take this step by step. 5 kilograms must be multiplied, or to know the amount of force of newtons, you have to multiply 5 by 9.8, as you can see here. Since the vertical forces are in equilibrium, we just put R equals 5 multiplied by 9.8. So if we're going to put this using the formula that I showed you previous slides ago, it's F equals U R. So we're going to do 0.4 since coefficient of friction is given, multiplied by 5, which is multiplied by 9.81. This will equal 19.6 newtons. So let's look back at the question. It says, will the box move? So this is the maximum amount of friction, 19.6 newtons, and the opposing force is 15. So the box will not move because there's the 15 newtons are 4.6 newtons less than what is required to even begin moving the object. Let's look at another question where the coefficient of friction is not given and we are supposed to look for it. As you can see in this question, a 400-gram package lying on a horizontal surface is attached to a horizontal string which passes over a smooth pulley. When a mass of 200 grams is attached to the other end of the string, the package is on the point of moving. Find U, or the coefficient of friction. So let's take this step by step as the previous problem. First, we draw the free body diagram. So the forces acting on the package are as shown here, as you can see from my mouse. And since the vertical forces are in equilibrium, we want to get R equals 0.4. 0.4 is the weight of the package in kilograms. So 0.4 g being 9.81, or the power of gravity, to find the total force or newtons of the package. So on the point of moving, let's take the formula of F equal UR. Since we need UR, there's 0.4 multiplied by 9.81 multiplied by the coefficient of friction, and F equals tension. So as the pulley is smooth, the tension on the string is 0.2 gram. This gives us 0.4 multiplied by 9.81 equals 0.2 over 9.81. So basically, coefficient of friction, as you can see here, you're basically putting F over T, making it the coefficient of friction half. As you can see, the formula is very simple. It can be used in multiple ways. Nevertheless, even if there are more than one unknown, even if there is other requirements, like for example, the first example, we had the coefficient of friction was provided for us, and we were just seeing if the force was enough for the object to move, and we concluded that it was not enough. In the second question here, it asked what is the coefficient of friction since the package is on the point of moving, and we concluded that it's half. How about let's take a more complicated problem. So this is a model of a car of a mass of 1.2 tons traveling along a straight horizontal road at a speed of 20 meters per second. When it brakes sharply, then skids. Skids is when the brakes of a car is applied with sheer force, and the tires do no longer spin and are at a stopping state, but the motion of the car keeps pushing it forward. But friction brings the car to rest. So this is a two-part question. First of all, there's the coefficient of friction given to us, which is 0.8. The question asks us to calculate the deceleration of the car, and the second part is the distance traveled by the car before it comes to rest. Let's look at the first part. We have to think about the value of the friction while the car is skidding, not before it moved. So this free body diagram shows the forces acting on the car when it's skidding. Since the vertical forces are in equilibrium, R equals 1200 multiplied by 9.81. And since the car is skidding, we must apply the formula for the coefficient of friction to find the force. So we're going to multiply 0.8, which was given to us earlier, multiplied by 1200, which is multiplied by 9.81, which equals 9,408 newtons. The friction causes deceleration, which is given by Newton's second law, as I stated earlier in the presentations, which is force equal mass times acceleration. Since it's decelerating, it's negative 9,408 equals 1,200, the weight of the car, and we're looking for the acceleration or the deceleration, so multiplied by the variable a. So you move the numbers around and you conclude with a equals negative 9,408 over 1,200, which will then get us the number of negative 7.84 meters per second. This is the value for the deceleration. Let's look at the second part. That the deceleration is known, which of the equations of motion can be used to find the distance traveled? Using v squared equals u squared plus 2as with initial speed u equals 20 meters per second, the final speed, which the car was brought to a stop, and the acceleration, which is negative 7.84. So let's plug in the numbers. 0 squared, which is the final speed, because the question did specify that the car was brought to a stop, equals 20 squared, which is the initial speed, minus 2 multiplied by the deceleration, 7.84, multiplied by the variable s. You solve the problem step by step. You conclude that s is 25.5 meters. That's the distance that the car traveled before coming to rest. So basically, in other words, friction can be used in multiple problems to find multiple solutions, and is a very simple concept that has no confusion and there is no um, complications in it. I hope this presentation has helped you understand what is friction and how problems can be solved, no matter what the problem asks and no matter how the problem is complicated, it's still the same simple steps. Starting from the free body diagram to using the appropriate and adequate equations as I showed in the previous examples. And I hope this presentation has helped you enough to clarify the idea of friction.